repercussion cases of COVID, we are going to have our classes online. So for that online, we have to demonstrate online. So for online that, we have to firstly make sure that your video clip should be shared and should be easy for your students guide. So for now, I'm going to have some experiments, firstly on the board and then on practical demonstrations. Thank you, and let's go. So welcome back, students. The game we start with is a Pitot tube. It's a very important experiment, a very important apparatus used to utilize to sort out the velocity of a flow. So before going further, I have chalked some sorts of bullets regarding the Pitot tube. So Pitot tube looks like this. Let us suppose it is the channel. It's a channel or water stream. And it is submerged in a stream. So what happens is here pressure develops a static pressure and there is a dynamic pressure. And how it develops? Now going backward to the background of that stream. First of all, we have known that it's a tube comprisement of some sort of arrangement like a U shape and having some sort of a 90 degree and converge at this end. So it has been submerged in the water. Okay. Someone is saying the static pressure has been developed. Static is just the rest position pressure, and suddenly it's the dynamic pressure. What had happened is water inside flows in this stagnation point and then rises up, and this static pressure develops here and converts to dynamic pressure. And above there is atmospheric pressure. So it is the game between atmospheric pressure and hydrostatic pressure, and it's sort of equilibrium positions. So this is the principle that how it has been submerged in the water. Water is flowing, stream is flowing, water is coming in that way. Velocity is being zero because it comprises of very minute opening. Stagnation point, velocity is 0, 90 degree angle has been made, provided, and it's going upward. The dynamic pressure has been reduced, and atmospheric pressure and gravitational pressure is acting downward, and on the other side, hydrostatic pressure is developing in the rightward and opposite direction. So, going further, stagnation point has been produced in which there is a minute hole and there is no velocity there. So here the velocity becomes 0 and it's interchangeably increasing its velocity again and again, and it's here touches and it's become again 0 and again it rises up and shows the head. But on the other side, one may observe that if it is going upward, so some sort of height gained by the water is going to be a little bit upward and then it's going to be downward. How? Because it's making its pressure head stable. So now Pitot tube is a mean when we remember that it's used to represent the velocity of a stream. Before going further, I also want to show that that's its looking of the Pitot tube. That's its look like. The gauges has been given, the measurements has been given. This is the point of stagnation. Just submerging in the stream, it will showing up the head. And through that head, we are going to find the velocity. It's a very simple. So there are two formulas used to demonstrate. We are also going to demonstrate experimentally on hydraulic bench. So actual velocity is a v is equal to q by a is a discharge per area, and another side theoretical velocity is equal to 2gh. So these are two components of velocity, which is actual velocity formula and theoretical velocity formula. So summarizing this all, it is just a tube comprised of some U shape and with stagnations. Velocity will come at some point 0, for example this point, water has been introduced ahead, and on the other side atmospheric pressure is just on the other side, and these are all is producing some sort of equilibrium. Unless and until they are going to produce some sort of rise in that water, but again they are going to balance each other and produce a good head. And head from head, which is pressure, we are going to find the velocity. A velocity is Q by A. The Q discharge is area when we find a good velocity in a second. So let's go for practical demonstration. Thank you. Hello instructor engineer Musa. Today in our hydraulic bench we are going to demonstrate Pitot tube behavior, as well as I am going to tell you how to find a discharge by using that tube of gauge. So just on the hydraulic bench here, by switching on, and to control the flow with a control valve. So our needed flow is this one. Now to find the discharge, which is Q is equal to V by T, volume into time, how much volume is occupied at the time. So for that, we are using this gauge for finding the volume, and to find the temperature, and for time, we are going to use this stopwatch. So firstly, use this valve to check up that control valve. Drain has been closed and the pressure at head is rising. So just stop. I have stopped on the stopwatch. So it's rising, and we are going to note that volume in the time. And about 12 seconds has been passed, and the volume is rising. Why? Because of the drain valve has been closed. We are expecting to stop that thing at about 10 liters. Stopwatch is still on, it is 34, 35 seconds, 36. Showing that the area that head is rising. From liter, we are going to make it in a cubic meter. As we know that 1 cubic meter is equal to 1000 liters. So we will convert it into a volume of cubic meter. So it has been raised at 8, 9 and 10. And at 10 we are going to stop that thing. I have just stopped the clock. Stopwatch, it was 1 minute 23 seconds. Now volume has been occupied at 10 and 1 minute and 23 seconds has been observed. So that's how we are going to find the discharge using that monometric tube and hydraulic bench. Now further, now for the Pitot tube, I am just fit my hydraulic bench. So now for the measurement, I am going to just put that in the flow, and we are going to measure the head. And from head, we are going to find the velocity at the Pitot tube. So I am closing that drain hole and put in that Pitot tube in that thing. Show that how it's happening. That's how I have placed that Pitot tube in a part of a flow when it's gaining its head. you must make sure that it's tightly gripped and tightly packed because of the no drain. And within a second I am going to check the head. And it's showing me about 10, and surely we have a 10. So that's also show me that how I have just put it on this and this. That was comparison that both of them shows 10 milliliter head. By having the head, we are going to find out the velocity from the formula, and that's how this Pitot tube can be used. That's all for today. Thank you.
Observation of the Pitot tube. Here the formula has been plotted, which is equal to V is equal to Q by A. Now the velocity will be founded in centimeters square. Now for the Q, we have a formula V into T. The volume into time is the formula. So how much volume has been collected in that manometer of the hydraulic bench divided by time recorded. So recording the time and a volume occupied, we would put it in the Q, and the area of the volumetric tank may be scaled out for that 46 liter of the capacity of the volumetric tank, and V has been found out for that. This is the actual velocity of the Pitot tube will be found out.